Okay, this is a video again following up on my Monte Carlo discussion. Okay, and just a very quick review. We saw that commodity prices, and we talked about the commodity prices having this mean reversion characteristic, and in theory, there's some kind of long-term cost of production that these things should stabilize at. And there's all kind of difference in volatilities, and there can be long periods of very low costs when there's surplus capacity, followed by extreme spikes when there's constraints on capacity, and that's what the volatility is trying to get at. And maybe it's better to try to make all your estimates about what the supply and demand situation is, or maybe we can look at some history. I used to be a firm believer in looking at production costs and saying, okay, trying to decipher all this stuff from history isn't that good. And then we showed you how to get the data. Oops. And then we showed you the big deal is that if you compute daily volatility, you get a very different volatility number. Let's look at Henry Hub gas prices. That's 72% volatility. When you look at the annual volatility, it's only 21. It could be due to seasonality, but more importantly, it could be due to spikes and uh, mean reversion and all the other stuff I just talked about. Okay, now then we said, okay, how do we actually estimate this mean reversion? And I said, well, okay, let's just try different levels of mean reversion. And whenever you do this, you put the mean price, and the last year's mean is always first, last year's is last, and you get a mean reversion factor. And then you do this. Okay, and now we're going to incorporate this. I introduced this before, but how do we get this into a financial model? And friends who predicted what's happening in the world again, and the risks associated with something that have a mean reversion are so much less than the risks that don't mean revert. I'm trying to think of, if you apply this to your life, maybe your job sucks right now, but you've got to really, you've got to, how to do the financial modeling. I'm just joking a little bit about that, but you have really good skills. You do. So you're going to have ups and downs in your life. But if your skills become obsolete, if somebody bombs the crap out of your building, it's so sad, or something like that, that's not mean reverting. I'm sorry to put it in those kind of contexts. Now, let's show you how you would incorporate this mean reversion in financial models. Now, I have made other videos, and you can make a financial model, and in about 5 minutes, am I slouching again? In about 5 minutes, you can, like the S, uh, 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 in about 5 minutes, you can incorporate, put a little random number in a financial model. So I'm going to close this one, and then we'll open the financial models. Okay. So I've made in this kind of set of files, we made a couple of files that just get the historic data on those commodity prices, and we try to get them for as long as we possibly can. And we're not as arrogant enough and fraudulent enough to suggest that we know exactly what's going to happen. Instead of that, what we're going to do is we're going to uh, 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 make various different estimates. We could put different mean reversion factors in and everything else. And then there's a file named Monte Carlo simulation. And oh shoot, I hope you don't hear the background. I do have a dog today, but he won't bark. He's really the I'm sure that was important information too. In this file, okay, here's what we do. I should have shown you this in the last file, but I closed it and these files get too big. How can we manage all this data? Now, if you make a VBA code, you can keep track. I suppose I have to open this. I suppose I have to open this one too. So I'm gonna, how can we, uh, uh, this is a, yeah, well, should we take this one? Okay. How can we, um, how can we get all this data in? Now, there are two different possible ways to do this. What I did is made this VBA code so that when we, how about, I'm going to run it. And if I do 500 simulations, that's okay. And then if I do 3,500, that's days. That will give us 20 years of data, and it'll go up and down, and we'll have a whole bunch. And we can put a starting price that's different than our mean price and see how it gradually gets there and all of that. And then what I do after you click on this is, come on, I hope this goes a little more slowly. This goes a little more slowly, and the big deal is how to make it kind of reasonable. And you can then put a little thing. I used to use this applications status bar, and that doesn't work very well. But you can see it's on the 200th simulation, and then it'll be in a minute it'll be on the 300 simulation. Now the problem is I had that other file open, so it's really slow. This is not nearly that slow, and you can make your little things so they tell you exactly what simulation you're on, so it's not as painful as just, if you don't have a screenshot like this is kind of like a psychology of running a model. If you don't have a screenshot like this, the Excel just sits there, and I would always say, I have no idea, are we in some kind of infinite loop, or are we really getting there? And then once you do this, it puts all of the different simulations in a in a different sheet. Now this is not really that hard. Now I say that with being an ass, because when I say not hard, you don't have to buy a new program for it, and the VBA code isn't really long, but it has some, I gotta admit, it's a little bit tricky. And what you do at the very end is, what I do is I say, I'm gonna put month by month uh, 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 data in my model, and I have to make a little thing where if it's the end of a month, which is there are 21 days in a 252 month, and if it's that one, we tabulate this monthly price, and at the very very end we put this monthly price in an output. And so once you do that, you can then have two different ways to incorporate the Monte Carlo simulation. One way, which I think is by far the best, is to just put this data into your financial model. And when you put this data into your financial model, so we're going to copy all this data, and I'm going to close this file now because it's got some random number stuff in there. And then I copy all this data into this model, and I say that we have 500, well, we have 500 simulations. If I put it on number one, it gets the first one. If I put it on number two, it gets the second one. And all this is, what did I do? I used the index function. And when I teach a regular old Excel class, I pound and I go crazy. You need to know index. You never need to know, oh, not quite, but hardly ever match index. Don't brag about using match index, please. And never use VLOOKUP, obviously, or HLOOKUP. Just use index and XLOOKUP or lookup or interpolate lookup, okay? That's really what you need. So we just take this thing, and we have a little, the row number is the row number is D3 up here. So on the second one, we go to the second row, and the third one, we go to the third row, and the simulation number is up here. So we just take this and grab the data. Just an index function. So on this one, if right now we're on simulation number 2, So the first price is here and the second price is here. And all you do then is when you go to your model, and in this one, I made a little model and I said, okay, we can use this horrible stuff that we do sometimes where we have a low oil price scenario. And we just stick a low oil price forever. And then we can compute a break-even oil price. And I used to be proud of all that. What a damn waste. Because oil prices don't stay the same. They go up and down, or refinery margins, or natural gas prices, or electricity prices in merchant markets. Okay, and so we could put these in, and then I'm going to come back to a couple of others, and then we have some debt, and I made a very simple debt analysis where we have 15 years of tenor, and it's just a flat, old, boring repayment. We put an interest rate, and we can put different levels of a cash sweep in. And we make a little model of a month by month model. And this commodity price comes from that one you just did. And in fact, what maybe I should do this sort of thing and put our simulation number in, and I hopefully put a little thing up here where we have our I call this a scenario number, but it's really the simulation number, so we can remind me to save this file, and we can do this stuff that is illegal according to all the stupid auditors and everything else. But we can then uh, uh, put a different simulation number in and get a different price. And if we have a lot of fixed costs, that's a dramatic increase in cash flow volatility, whereas if they're variable costs, it's a lot less, so you can model those kind of things. Those are the most fundamental things you should have learned in some finance class once. Okay, and then we put our normal kind of debt in, and when we have a cash sweep, our cash sweep, all the action always occurs not in the debt schedule, but in the cash flow waterfall. We make a little cash flow waterfall, and this is always the cash flow sweep. Always has a minimum and a maximum function in it. It has both in there. Okay. Uh, the okay, that's enough. And then so we don't sweep anything because we've got negative cash flows. If we've got negative cash flows, we have to say, okay, we can't pay the debt. We're going to defer it. And some of these commodity price structures, directly or indirectly, if it's a production payment loan, then if you're maybe you take less oil out of the ground, and maybe you can't really defer it. But if it's a refinery project or others, there are often specific provisions that you can defer some of your repayments. Or you can call it a default. Who cares? And that is modeled almost the same way. The action occurs in the cash flow statement. So this is just, again, we have negative cash flows, and we just do a very simple thing without a limit and say, okay, well, we take the maximum. If it's a negative number, we have to defer it. If we defer it, then we better pay off the deferral. And I say we're going to pay off the deferral before we have a cash sweep. And this is just another, we take the maximum of the cash flow, but we only defer it until we're finished. And then there's no deferral after here because you've paid it off. And this amount you've paid off is not the cash flow, but it's how much debt you have at the beginning of the balance. It's all with maximum and minimum. I consider that, kind of an old thing, and you just have to get used to the min-max. And then when you do this, okay, the nice thing about our little thing here is that, well, let's do it over here, and then let's illustrate really this cash flow waterfall, and we can try different. This has got 100% cash sweep, and in this case, we have a deferral, repayment, deferral, repayment. That's a deferral here. Then we repay it all because we got a nice big price spike here. And then we can use a cash sweep to protect ourselves against the future. And that means our debt service will be a little bit less than it would have otherwise. It'll repay earlier. And then we have another problem, and then we pay it off because we have a tail, and then we are able to pay it off by the end. But if I go through another scenario, and this is a random walk scenario, okay, so this has high volatility. In this case, we're able to pay it off. In this case, we're not able to pay it off. And we can look at, in this case, we just paid it off. And let me find another one where we didn't. Come on. Come on, come on, come on. Here, we didn't pay off the debt. And the amount of the debt that we don't pay off is just in our financial model. And maybe this is a different way of looking at some of your financial model. I've done this for ages, decades. And I take the closing balance at the very end of the life. Now, what just happened? This was scenario 18. Just a minute. Let's find another one. In this one, we can't pay off 143. And oh, this is the deferred debt balance. We see how much of this default balance that we cannot pay off. Okay, so you've got to set up your model to show what's going to happen in bad cases and what's going to happen in good cases because we've got some volatility. And in other videos, I've said, don't worry about this. Pay off the debt, have a cash sweep, but then refinance it. If it's in the downside, well, everybody's kind of screwed. The bank maybe too. Okay, and we have to decide how much debt we have. Of course, if we put ups, this one I can't do anymore. Shit, I can do it like this. And our debt, just temporarily, our debt is equal to the amount we applied times 1,000, I think. Okay, and then we can look, and again, if we put more debt in, then we can see at what point we don't pay off the debt. Please, I struggle with these graphs, and I suppose I'll show you the graph. I mean, at the very bottom of the financial model, I kind of have a little section, I hope, for the graph up here, and you got to kind of look upstairs in the financial model, and when you do it, you have to kind of put a stacked graph for all the things that are in the cash flow sweep, the cash flow waterfall, like the sweep and the deferral, and then for the top one and all that. But people are really good at these graphs. So, okay. The key is to be able to show people what's going on. A lost thing in this craziness about about uh, sorry, about auditing. It's so horrible. Let's take another scenario. I'm looking for a scenario. This is one. Yeah, let's take this one. Let's see what happens in this one. In this one, we have a couple of big cash sweeps. If we didn't have a cash sweep, which means we allow the dividends to be paid, what happens is that, oops, it's not, it's defaulting if we don't have a cash sweep, but if we protect ourselves and get paid off when those prices are really high, that's why that man from Enron in a class once said, a cash sweep, that's in from his Texas, it's a good time cash, a covenant, okay? It was a good way to say it. Enron people were the smartest people ever, I guess. Okay, now they're into the biomass, I hear. Okay, so we can see how the cash sweep affects things. Now, once we do all of that, all we're now to make this Monte Carlo work. Now, go around. And when I would make in 5 minutes, make a Monte Carlo simulation, instead of taking that database we made, you could just put some random variation in here and put your time series. And again, everything's about the time series. That's got a mean reversion factor in it even, and a volatility. I don't have a volatility. We could do all of this, and every time we press a button, we get a different number, and then we don't know how many simulations to do, and we have some things that don't look quite right. But the good news about using the same number of simulations is we don't have kind of any bias to really worry about, because we can change this cash flow sweep and change the level of debt and run it against the same kind of prices that we put in the audit sheet. Okay. And when you do this again, because of the mean importance of mean reversion, because of the importance of mean reversion, you just copy another set of prices that have mean reversion and don't have mean reversion, and then you can at least experiment and say what's going to happen to our financial model if we have a thing going on. And at least you can, and maybe I'm rambling a little too much right now, but at least you can explain to your boss, okay, here's what happened if we don't have a different level of debt. So we're using this Monte Carlo as a way to kind of size the debt and evaluate some features of the debt for things like a cash flow sweep. Now, if you make a data table, wouldn't it be nice? Now, this is the scenario that has a really high level of default because we erroneously don't have a mean reversion. And if somebody in your bank or somebody else says, oh no, and think about this. I need to decide how much debt to put in to my project, and I need to know if I should put a cash sweep in or not. And how would I evaluate it? Well, you start talking, oh, wow, my bank, blah, 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 cash flow sweep. In this transaction, we had this. In this transaction, we had this. And you start using big words and saying, no, 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 we can't do this, we can't do that. How could you quantify it? How could you do anything reasonable to quantify it? And that's where Monte Carlo simulation could actually help. But you have to get the mean reversion right. If you don't get the mean reversion right, it's a lot of real complete junk. And you go and you say, here's what I think the mean reversion is. I might be wrong. It might be a little higher, might be a little lower, just like the oil price might be a little higher or lower. And you can get some results. And so here we put different levels of debt in. And then for each different level of debt, we run all of our simulations, which I put 500 in. You could put 20,000, and then you'd be sitting there with your computer for a long time. Maybe you could put it on a second computer or something and just run it. And you can see if you really get different results instead of reading some book, which I did on Monte Carlo simulation. I think even if you look at the chapters I gave, one day I'm going to get put in jail for this, I guess, because I put this Monte Carlo simulation book, I think, in here. Okay. Okay, these are all given to me so that I can't get in trouble for this. Economics book, where's my Monte Carlo simulation? Somewhere here. Okay, I don't know. Okay, enough. Okay, you can look at those. Sorry, I couldn't find it. I didn't read very much of it. Okay, it tried to tell you how many simulations you should do and all the rest. You just try it yourself. Don't be afraid of this. Don't be afraid and say, I got to do it. The only thing to be afraid of for me is getting the mean reversion correct. And that mean reversion, again, is a very philosophical idea that things go in cycles and they come back. And that's a much lower risk than things that go up and down and never come back, like fashion obsolescence and those kind of risks. It's just a real way to think about risks, and then you put some mathematics around it. Okay, and the only thing left to do is, well, I'm just going to start this. So when I press this, I said, okay, I'm doing 500 simulations, and then I put a little thing and it says what simulation you're on, and then it shows when you're having a default. And that's the first row and the first column. Okay, I'm going to take people through it because I want to make sure and walk through some macros to incorporate it. And if we only have 600 of debt, you can see that the defaults are coming here, and at least psychologically, maybe it's not quite as bad as having to just sit there. At least you can see something. There really, for me, is some psychology in financial modeling going on here. Okay, and then eventually we'll get to the second column row, and we'll have more defaults because we have more debt. And then and we're only there. Okay, hello. And then I'm going to just break this just a minute, okay? And then I'm going to, then once we do that, let me show you what you kind of finalize it. You make, basically, it's making a data table yourself, but you go around the rows, and for each row you put a different debt balance in, and you change the input for the debt balance. You go around the columns and put a different debt sweep, a cash sweep in. That's, yes, across the columns. The rows are the debt balance. And then you keep track of the amount of debt that's not repaid. Is that hard? It is. It is. And sorry. And you go around for each debt balance scenario and each cash sweep scenario. You go around and around and around each of the simulations. And finally, and that's where you do your little thing to show the what's going on. So that's about half the code, is just to show you what's going on. And once you're finished with all of these, you figure out how to get it just pasted into the data table. And that's a little bit tricky. To get it pasted into the data table, you have to do this redimension business, and so you have to find out how many rows and how many columns you have, keep track of those rows and the columns. You get the average default for each across all the 500 simulations, and you just stick that in. So this code, yeah, okay. It takes about a page and a little bit more than a page, okay. And you can try to buy at risk or something like that, or just crystal ball or something like that. I haven't looked at that for so many years. I don't know what they even have in there anymore. But this you can do yourself, and you try to be efficient, and you really understand what's happening. And again, the final result of all of this is that there's an enormous difference in the results, but for whether you, in case you have mean reversion or no mean reversion. This first one is the scenario where we have some we have a random walk, and we use the annual volatility of oil, which is about 24% the way I computed it. Some people say it's more, some people will use a implied volatility and all that stuff, fine, whatever. And this is the case where we put some mean reversion in. And the results are so very different. And you should structure your financing around the risks. And I'm going to stop with this perhaps. If we have a solar project, we have seasonality, and we better do some sculpting for the seasonality. And if we have a fixed price, we don't really need a cash sweep. We don't need a deferral. We need to structure the debt really careful so we can maximize the amount of debt and still get our coverage ratio. That's structuring maybe a solar project. If we have a flat transmission line or something like that, well, then you want to get the debt size right, but you might have a flat, you might just have the sculpting going up with inflation and deal with some inflation risk. dealing with some minor risk. The structuring of that debt might be very different than the solar debt. If you have an upstream oil where the amount of, you know how many reserves you are, but you could take those reserves out. I don't know how it all works, but you take those out at different time periods. Well, then you better structure the debt with a production payment loan where the production payment loan is the repayments are a function of how much oil you essentially take out of the ground and what the present value of your reserves are. And in each case, we're structuring the debt size and the debt repayment according to the risks. And that's the beauty of project financing. And if you've got some kind of refinery where you've got big volatility that's relatively short-term volatility that's got a lot of mean reversion in, then you put a cash sweep in and maybe a deferral provision because you know there's going to be volatility, but you say, it's okay, we're going to get some mean reversion. And I hope I could go on and think about different structures, but when you really take this gigantic step backwards and say, what are we really doing in project finance? It's fascinating. It really is, because you're structuring, you're really thinking about the financing, how much money we can put into the project, and you're doing that as a function of the risks and the characteristics and the physical characteristics of it all. Okay, and that's enough of this. Now I'm going to try very hard to make some other videos uh, uh, about the macros and some of the technical details. Maybe nobody will